Okay, hey guys, this is just a quick video on the derivative rules. So, these are the ones we learned in class. So I'm just going to go through them super fast in case you missed them. So we have got something called a constant rule. So that's the rule where if we have a function like f of x equals c, let's call it, where c is a constant, then the derivative of that function is just 0. So here's an example with actual numbers. Say you had f of x equals 7. The derivative of 7 is 0. Or let's say you had g of x equals the square root of 3 pi. The derivative of that is still 0. So the derivative of any constant is 0. Okay, moving along. Power rule. This is a super helpful one that you'll use all the time. So here's the power rule. So if we have a function, f of x equals, let's just say x to the power of n, where n is some real number. If we wanted to find the derivative of that function, f prime of x, the derivative would be, you just take the exponent, you just take the exponent, whatever that is, put it as now the coefficient in front of your variable, so nx, and then you subtract 1 from your original exponent, which so becomes n minus 1. So let me give you an example with actual stuff. So if we had g of x equals x to the power of 5, the derivative, g prime of x, would be 5x to the power of 4. So this exponent became the coefficient, and our exponent got subtracted by 1. So like a more complicated example, say we had h of x equals 3x to the power of 4. H prime of x would equal, that 3 would still be there, but now we've got the 4 as a coefficient as well, and now we would have x to the power of 3. So altogether we'd end up with 12x cubed. Okay, and then a crazier one would be, say we had f of x equals, okay, this isn't that crazy, but 5x, if you want to find the derivative of that. Okay, so x just has an exponent of 1 on it. So if we moved that 1 out front, it would still be a 5, because 5 times 1 is 5. And then we'd have x, and then 1 minus 1 would be 0. So with an exponent of 0, we know that anything to the power of 0 is equal to 1. So this actually just equals 5. Okay, awesome. And then taking this a step farther, let's say we had g of x equals the square root of 3x. So remember, we can turn square roots into fractional exponents. So instead of a square root of 3x, it's actually 3x to the power of a half. Okay, time out. Let's actually just do the square root of x for now. Okay, so remember, we can turn a square root into a fractional exponent, so that would become x to the power of a half. So then if we wanted to take the derivative of g of x, so g prime of x, it would end up being half x to the power of, so we're subtracting 1 from a half. So if you subtract 1 from a half, you get negative a half. And we never want to leave our answers with fractional exponents or negative exponents. So if we have a negative exponent, we want to move that to the denominator. So it becomes 1 over 2x to the 1/2 to make it positive. And then we know that fractional exponents can be turned into roots. So a half is just the square root of x. So there you go. That is the constant rule and the power rule. Ooh, wait, one more thing. Fractions. So let's just do another example. Say you had h of x equals 3 over x. So you can actually treat this one like a power rule question, because you can move your denominator into the numerator by making it have a negative exponent. So right now it's got an exponent of 1 on it. So we can just make that x to the power of -1. So that way it'll just be like a normal question to us. So if we want to find the derivative of h of x, just take your exponent, -1, and put it in front of the 3. So now it becomes -3x. And then we subtract 1 from our exponent, so that makes it -2. So that's our derivative, and remember we don't want to leave negative exponents, so we would write that as -3 over x squared. Awesome.